Pure mathematics is in its own way the poetry of logical ideas by Albert Einstein. Welcome back again to my channel Mathematics a Dream Come True. Subscribe my channel and like my video. Lot of surprises this time. So let's see what's there. If you really want to see me live after seeing my video, you can all download Unacademy Learning app. I am there as a mathematics educator. You can use my code Taruna01, write all capital letters with 01. What I am going to get this time is mathematics, which will help you to clear your competitive exams. This is my session 1, right? And if you want more sessions, please subscribe, like my video. Definitely I'll upload time to time whatever will be possible from me, ASAP, as soon as possible. So, topic, theories of equations. And what I'm going to teach is right now polynomials. You've already learned, or you might be learning this topic. So a little base on this before we start. So how do we represent a polynomial or an expression? An expression of the form a naught xn plus a1 xn minus 1 plus so on plus an. So the power keep decreasing and the coefficient I've just named as a0, a1, and ultimately the x power becomes 0, x0. So x0, as we all know, is 1. What is a real polynomial? A polynomial with real coefficients is a real polynomial, right? Real coefficients. Degree of a polynomial. Right? So what is the degree of the polynomial? Highest index. अब ये word मैंने index use किया. So you can also use power for this, right? Of a variable x. Occurring in a polynomial. Okay? 0 degree of a polynomial. What do you mean by 0 degree of a polynomial? Let me explain this with an example. Now if you have c is equal to c x naught, that means you are just left with a constant term, right? अगर सिर्फ constant term बचेगी तो degree is equal to 0. Be very careful. Types of polynomials. ठीक है, कितने टाइप्स होते हैं? बहुत सारे होते हैं because polynomials have n degree, we can go up till n degree. So types of polynomial, if I'm talking about, right now what I'm going to talk about is linear. So I will just give the example. Linear polynomial means like f of x is equal to ax plus b. That means your degree is 1. Right? Then I talk about quadratic polynomial. That means degree is 2. So if I talk about this, x square, ax square plus bx plus c, right? Then I talk about cubic polynomial. Degree is 3. So this way we keep talking about different polynomials. Now we know about polynomials. Now what I am going to talk about is what you have learnt in grade 9, remainder theorem, and factor theorem. So when I talk about remainder theorem, I will just explain not in wording, with just representation so that you understand a little better. So if I have a polynomial f of x and I say it is divided by x minus a, right? And remainder is f of a. Okay. So how will we represent it? It means f of x is equal to x minus a qx plus r, है ना? Basically this from where I've got this, हम बचपन से division करते हैं, तो we know that dividend is equal to divisor into quotient plus remainder, right? But now I know that my polynomial is divided by x minus a. So if I use x is equal to a here, what will I get? I will get f of a is equal to a minus a q of x plus r. That means my remainder now is f of a, right? Remainder is f of a. Or we can also say this is equal to 0, right? We can say f of a if I'm saying f of a is 0, right? That means my remainder is a, or a is the 0 of the polynomial. Then it becomes a factor theorem. That means this leads to our factor theorem. That means what I am saying. Now if my remainder is 0, then a is the 0 of the polynomial. For remainder theorem, you are getting r is equal to f of a. And if this becomes 0, then it becomes the factor theorem. Like, then I will say x minus a is a factor of polynomial f of x and remainder is is 0. But I think these concepts are very much clear to you. So let us move on to a difficult concepts which I'm going to talk about now. Right? Now let us talk about an important theorem which is called as fundamental theorem of algebra. It states every polynomial function of degree greater than equal to 1 has at least one zero in the complex number. What do you mean by this complex number? So let's represent it in mathematical form to make it more understandable, right? So if I have f of x is equal to an x raised to power n plus an x raised to power n minus 1 plus so on plus a 1x plus a naught, right? So now we know that n is greater than equal to 1 as we have discussed above. So let's see, there exists at least one h which belongs to complex numbers, which I am representing by C, right? So a n h n, so obviously if h I am talking about, I will replace by x plus a n minus 1 h n minus 1 plus so on up till a1 h plus a naught is equal to 0. Now from this equation, right, it is deduced that a polynomial function, it is deduced that a polynomial function of degree n has exactly n zeros, right? That means f of x will be equal to a x minus r1, x minus r2, so on up till x minus rn, right? So this is how we have deduced that every equation of the nth degree has n roots and not more than that. Be very careful about this. Has n roots and not more than that, right? And no more, or I can just use the word no more. Please, please, please just note down this. Very, very important note, okay? Further few important points which I feel you should note down is, right, sum of zeros of a polynomial may repeat. Sum of zeros of a polynomial may repeat, okay? If alpha as you all know is the root, is repeated m times, then m is called multiplicity of the root alpha, Okay, then another point which is important is now if you have real numbers of the form root 3, root 5, or say root 5 plus 3 and so on kind, these are called quadratic surds. Please note down this new word, quadratic surds. Now if a and b, say now I take root a plus root b, and I say a and b are not perfect squares, then it always have a conjugate of the surd, a conjugate of the surd. Now what I mean by that means, if I say I have one root which is 2 plus root 5, right? And I have to write the following conjugate roots. So that means it becomes x minus 2 plus root 5 and x plus 2 plus root 5. Okay. So let me show you an example and a question related with it. Now if you have a question, find the polynomial function of the lowest degree with integral coefficients root 5 as one of the zeros. Right? तो कैसे करेंगे आप इस क्वेश्चन को? Very important. What are we going to use now here? है ना? Let's see what are we going to use here. So I know that root 5 is a surd, right? Solution. Root 5 is a surd because it is not a perfect root, right? है ना? तो अगर ये perfect root नहीं है तो I can also take root 5 to be like how? इसमें मैं क्या करूँगी अब? ठीक है, अब मुझे पता है कि मुझे एक polynomial function बनाना है, so lowest बनाना है, so I will take my polynomial of lowest degree 2, right? तो मैं polynomial I will make with lowest degree 2. ठीक है, obviously lowest degree तो 1 होती है, तो वो तो बहुत easy है, x minus root 5 कर दो, right? For lowest degree 1. But if I have to make it for 2, that means I will take this polynomial now, ax square plus bx plus c, right? अब अगर मैं ये ले रही हूँ and I say that my a, b and c are real numbers or maybe rational numbers, I can say, right? So then I will get p of root 5 is equal to 5a right? Plus root 5b plus c equal to 0, है ना? So I will now get 5a plus c plus root 5b is equal to 0, right? Now we know that root 5 is irrational, है ना? This we are very much clear on it, right? So that means f of a plus c is equal to 0 and b is equal to 0, ठीक है? तो c comes out to be equal to minus 5 of a. So my required polynomial now becomes ax square minus 5a, right? So I can also say now that root 5 has a conjugate root minus root 5 from here, right? Because if I equate it to 0, then x square comes out to be 5. That implies x is equal to plus minus root of 5. So if you're all clear with the conjugate roots, then now I will talk about another theorem, okay? Another theorem which is identity theorem, ठीक है? Right? So let's know about it. Let us learn about this identity theorem. So what is identity theorem now? A polynomial f of x of degree n is identically 0 if it vanishes for at least n plus 1 distinct values of n. Values of x. Should I repeat again? A polynomial f of x of degree n is identically 0 if it vanishes for at least n plus 1 distinct values of x. ठीक है? So proof I will not teach. I will just teach how to use this theorem with an example. ठीक है? But before that, just a little glimpse. If I have f of x is equal to a x minus x1, x minus x2, and so on up till x minus xn, and I say that alpha n plus 1 be the n plus 1th value of x at which fx vanishes. Don't worry, अभी जब मैं एक एग्जाम्पल कराऊंगी तो you will understand it little more better. So f of alpha n plus 1 is equal to a alpha n plus 1 minus alpha 1 and so on alpha n plus 1 minus alpha n is equal to 0. So let's take an example to understand this. How the identity theorem will help you. Now this example which I am teaching you is very common, and so let's see how we go about this example, right? So if I have, let P of x be a monic cubic equation such that P of 1 is equal to 1, P of 2 is equal to 2, P of 3 is equal to 3. Then find P of 4. Okay, now what is the solution? Now, let's see the solution of this. Now px, I have already underlined this word monic because I thought you will ask me what do you mean by this. With coefficient, that means we have the coefficient of highest degree will be 1. Okay, so now let qx is equal to px minus x. Why minus x? Now we are using that identity theorem, है ना? अपनी identity theorem हम use कर रहे हैं. ठीक है? So what are we going to say? So that means my q1 का मतलब हुआ p1 minus 1, है ना? q2 का मतलब हुआ p2 minus 2, right? And q3 means p3 minus 3 all are zeros, है ना? हमने यही बोला था ना identity theorem that it vanishes. So accordingly I am doing it. So now I will get q of x right is equal to x minus 1, x minus 2 and x minus 3. इसका मतलब px अब हमारा क्या होगा? As I have discussed identity theorem के हिसाब से qx plus x, right? Now that means अब इसको अगर मैं expand करती हूँ I will get x minus 1, x minus 2, x minus 3 plus x, है ना? So px अब क्या हो जाएगा हमारे पास? Now I am going to substitute 4 in place of x, right? 4 in place of x, 4 in place of x here, 4 in place of x here, and 4. That means now I am calculating my p4. So if I calculate my p4, I will get 10. ठीक है? So instead of x here, basically I am going to use 4. Clear now? I hope you have understood the identity theorem, right? In my next video, I will be talking about polynomial equations, stay tuned all of you. I will be talking about rational root theorem. Okay, soon I will get, if you like and subscribe, and also about Vita's relation, okay, and how they are used in different types of example, and last but not the least about symmetric functions along with examples. go through this, and I hope it will help you a lot. So I'm concluding today's session, right, bache? So what I'm concluding it is with, as I told you, I will be talking at the end about my live sessions on Unacademy. Live sessions on Unacademy. You need to use my referral code to enroll yourself for plus. यहाँ पे special classes भी होती हैं which you can have a view, जिससे आपको ये समझ आ जाए हम लोग क्या करते हैं. So what we have is, we have live sessions, discussion with peers, structured classes, individual attentions, unlimited access, daily practice questions, success and confidence, mentor guidance always 24 hours. और खाली आप मैथ्स नहीं पढ़ोगे इसमें, यू कैन हैव अ व्यू. दिस कोर्स इज ऑल्सो कॉल्ड फाउंडेशन एंड NTSC कोर्स. प्लीज सब्सक्राइब फॉर दैट, फाउंडेशन एंड NTSC कोर्स, राइट. इसको आपने सब्सक्राइब करना है, ये कोड यूज करना है. यू विल गेट कंसेशन फॉर 10% यूजिंग दिस कोड. एंड अभी वहाँ पे मेरा ये जो मैं आपको लेक्चर दे रही हूँ, वहाँ पे मैंने एक लॉन्च किया हुआ है कोर्स फॉर द कॉम्पिटिटिव एग्जाम्स which will end in October. So बहुत बेनिफिट होगा आपको. ये वीडियोस तो आप देखो, I will keep bringing, but this will benefit you more, right? So waiting for you to enroll to this. So at last, not the least, thank you with coming again, right? I promise you I'll be coming soon. Okay, use the referral code. Let's have an interactive sessions rather than recording sessions. And do subscribe my channel if you want or more videos, right? And bell ring कीजिए और like ज़रूर कीजिए, comment भी कीजिए, so that I understand you have got the knowledge on this. Thank you so much.